Yes, let's do it. So these orbits don't get talked about quite as much because an eccentricity that's greater than or equal to 1 is going to be unbound. And so anything that is bound to the solar system has to have an eccentricity less than 1. But these orbits are totally possible and they definitely exist. So here, the black orbit has an eccentricity of 0, so it's exactly circular. The red orbit has an eccentricity between 0 and 1, so it's elliptical. The green orbit is E equal 1, so that's the parabola, and the blue orbit is E greater than 1, so that is the hyperbola. Now for these greater than 1 orbits, you can tell that they are open, they're not closed, they do not return back to the same point. But they still have a para-apse, they still pass by at a closest point. Some famous objects that have unbound orbits are interstellar interlopers that we recently detected in the past couple years, Umeamea and the comet Borisov. Ooh, this is such a good question. Okay, so the thing that makes the atmosphere breathable for humans is oxygen. As long as we have oxygen at the right pressure, we can breathe, even if it's just pure oxygen. And, of course, the lack of toxic gases. So if you had too much things like CO or CO2, then that would not be breathable for humans. Now, here on Earth, the presence of oxygen in our atmosphere is because of life, and we would not have our lovely breathable atmosphere if not for the rise of life a long time ago. But, so this is what makes oxygen seem like a promising biosignature on other planets. However, there are a couple false positive scenarios where basically a non-biological source could produce a significant amount of oxygen in the atmosphere of an exoplanet. Now, some of these processes also produce poisonous gases, so it would not still be breathable for humans, but it is possible via photolysis of water. So basically you break apart water into H and O2, and H is lighter so it escapes and leaves behind enough O2. Ooh, what a great question. Okay, so something that passes the event horizon of a black hole can never escape. And so these jets that are coming from a black hole are not actually coming from inside the black hole. They're coming from the material that's being accreted onto the black hole. So there's an accretion disk that's feeding matter onto the black hole, and the black hole is actually accreting some of that, so it's going past the event horizon and becoming part of the black hole. But not all of that mass can actually directly accrete onto the black hole. And so through some mechanism, which actually is still unclear exactly how this works, it's been proposed by frame dragging or magnetic fields or some combination of these things, but the basically excess material that can't get directly accreted onto the black hole actually gets shot out at the axes of the rotation of the accretion disk in these huge relativistic jets that can be over a parsec long, which is really crazy. I got this question and variations on it a lot in my video that I made about the moon having the same spin period as it has an orbital period around the Earth. And so I want to try and answer this, but it's really hard to explain in 60 seconds, so just real quick to the point. No, this is not a coincidence. It's because of gravity. In fact, it's due to the differential force of gravity across the body, which leads to tides, which creates a tidal bulge on the secondary body. And when the secondary body is rotating, that bulge becomes misaligned. And so then there is a kind of force that acts to restore that, a torque that slows down the rotation of the secondary body, and over time it slows it down to the point where its spin is the exact same as its orbit, and so that the tidal bulge is always aligned and the same side is always facing the Earth, assuming a circular orbit. This happens all over in the solar system. All of the major moons of Jupiter and Saturn, Pluto and Charon are actually tidally locked to one another because they're pretty small. And the Earth in 50 billion years or so will also be tidally locked to the moon, but that's not going to happen because other things are going to happen in 50 billion years, but whew, that's it. I want to answer this because I don't want to discourage anyone from asking me questions. I absolutely love answering y'all's questions. When I say an illegitimate question, I don't mean a stupid question, a dumb question, nothing like that. I'm happy to answer questions at any level. An illegitimate question is a question that you don't actually want an answer to. You're only asking it to try and trap me into saying something that you think is going to confirm a conspiracy theory or give you a chance to talk about a conspiracy theory. So as long as you actually want an answer, please, please, please feel free to ask me any questions. I never want to discourage anyone from doing that.
Want to know where your math level is? Here's 12 questions by grade level to see where your math level is. All these questions can be done mentally, but you don't have to, and you can pause at any time you like. Ready? What's 4 plus 4? What's 25 minus 8? What's 12 times 9? What's 1/2 times 1/3? Which number here is divisible by 12?
Did you know that there is a bigger, better asteroid belt in the outer portion of the solar system? The very first KBO, or Kuiper Belt object, was detected in 1930, and you may know it as the dwarf planet Pluto. We didn't detect any more KBOs until the 1990s, but now we've detected thousands, including more dwarf planets like Makemake and Haumea, and other Plutinos that are in a 3-2 resonance with Neptune. It's a really cool part of our solar system, and it's the subject of this week's Science Monday video. There are so many amazing objects in the universe that we've detected. There are planets where it rains diamonds. There are black holes billions of times the mass of the sun that have these relativistic jets that shoot out across the universe. But one of the most unique and crazy places that we have ever seen, instead of looking up, we need to look down. A planet where it rains water, where there are things on the surface that have influenced the atmosphere over gigayears, where there is life. There's only one planet Earth that we know of in the entire universe. And that's what we're talking about for this week's Science Monday video. Oh no! Let's do a demonstration. Okay, say that this is the Earth, and I'm the moon. So if I orbit the Earth without spinning, that is, my body does not spin, so I stay facing this direction at all times, notice that the Earth actually gets to see all different sides of me because I'm not spinning. But if I did spin while I was facing the Earth, so that the same side of me is facing the Earth at all times, notice I have to spin. I have to face different directions in order for that to happen. And in fact, in order for that to happen, I have to spin once for every one time I orbit, and that is what the moon does, and that is why we always see the same side of the moon.